we can substitute 1 by x dx with du. So here we put du, the variable with which we're going to integrate, with respect to which we're going to integrate, and 1 by natural log of x, which is here, as we assumed initially, 1 by u. Okay, so we have the situation 1 by u du. So the integration would give us natural log of u, which means natural log of x, because u is equal to natural log of x, plus c, the constant of integration. Yes, we solve now some basic cases of differentiation. Okay, so for example, we have a form which says f of x plus g of x. So the differentiation would be equal to d by dx of f of x plus d by dx of g of x. Yes, and we can have numeric values, proper functions. Let's say the case is f of x is equal to 3x square and g of x is equal to 5. Okay, so we have a form which says d by dx of 3x square plus 5. So we go about it doing d by dx of 3x square plus d by dx of 5. So 3 dot d by dx of x square plus 5 by d by 5 dot d by dx of 1. You see, so 3 dot 2 dot x plus 5 dot 0, which means 6x plus 0 or 6x. So for this function we have this sum of two functions, we have this derivative. Okay, in general, as I mentioned, d by d in the previous segment, d by dx of x to the power n is equal to nx n minus 1, and d by dx of, let's say, natural log of x is equal to 1 by x, and d by dx of sin x is equal to cos x, and d by dx of cos x is equal to minus sin x. From ab initio we know that d by dx is, you see, delta y by delta x, and d by dx basically is equal to delta y by delta x with limit delta x approaching 0. Okay, this is the theory, actually the gradient, the slope between 2 points. Let's call this point A and this point B, and these points are situated on a function which goes, these points A and B basically are situated on a function, point A, let's say here, point B here. So this very much becomes the dy by dx with delta x approaching 0, delta y by delta x. This is what I'm trying to show. on a plane. Yes, but these are the very basics, and we will get to the problems once again. Plus or minus doesn't matter in between the two functions, f of x plus g of x, or f of x minus g of x. Yes, and now we solve a problem which says there are two functions, but they are multiple, like they are product. This is called the product rule. Product rule. And in this case, we have a situation where we are supposed to find the derivative of f of x dot g of x, where f of x, let's say in our case, is an example, is equal to 5x4, and g of x in our case, let's say, is 2c, where c is a constant. Yes, so what we do is we write it properly. d by dx of 5x plus 4 dot 2c. Okay, now we can either multiply the numbers and simply go for derivative, keeping the constants outside derivative, which is how we do it. But the point is to explain the product rule, and the product rule says that the derivative is equal to first function into the derivative of the second function plus second function into the derivative of the first function. Okay, so 5x4 dot 2c dot d by dx of 1 plus 2c dot 5, and now dot 4x cube. So 5 into 10 and c, and then but d by dx of 1 will be 0, so everything will become 0, but we still write 10cx to the power 4 plus 0 plus 2 4s are 10, and 10 4s are 40, 40cx cube. Yes, so 40cx cube becomes derivative where c is constant as we assumed initially. And now the quotient rule, which is for fractions, and in this case we have let's say u by b and d by dx of u by b. Yes, and this is equal to divided by b square b d by dx of u minus u d by dx of v. Okay, this is the quotient rule, and let's say u is equal to f of x is equal to 3x squared plus 1, and alright, just keep the function simple. 4x cubed, let's say, and v is equal to 2x, let's say. V is equal to g of x is equal to 2. Alright, 4x plus 1 and 4x plus 3 and 2x plus 1. So these are the two functions, and they're in the form of a fraction u by v, which means we have a form something like this. We have a form like f d by dx of f of x by g of x. So so what we will do is we will put the g of x in the denominator, mix the square of it, and then g of x here, and d by dx of f of x, and then minus, and then f of x in the beginning, and then d by dx of g of x. Okay, so d by dx of uh, d by dx of u by v, now simply put, is equal to 2x plus 1 outside, and d by dx of 4x plus 3 minus 4x plus 3 outside, and d by dx of 2x plus 1. Okay, and under in the denominator we have 2x plus 1 whole square. Okay, so we don't expand the square for now, we see what happens. 2x plus 1 up here, square here, up here, and then we solve this one. D by dx of 4x is equal to 4, d by dx of 3 is equal to 0, and then 4x plus 3 outside, and then d by dx of 2x is equal to 2, and d by dx of 1 is equal to 0, so 2 plus 0. Yes, you see, so this is what it gets down to. 2x plus 1, 4 into 2x plus 1 minus 2 into 4x plus 3 by 2x plus 1 whole square. Okay, so 8x plus 4 minus 8x plus minus 6 by we open it up, 4x square plus 1 plus 2 into 1 into 2x, which is 4x. Okay, so this becomes 8x minus 8x is 0, and 4 minus 6 is minus 2, so this becomes minus 2 by 4x square plus 4x plus 1. So this becomes the derivative of this fraction. Yes.